Good morning, dear children. Today we are going to study about trigonometry. In the last class, we have discussed about the basic concepts of trigonometry. Though we studied, trigonometry is the branch of mathematics dealing with the relations of the sides and angles of triangle and with the relevant functions of any angle. That means we have studied trigonometry is the study of the relationship between the sides and angles of a triangle, especially the sides and angles of a right triangle. And we are very much familiar about right triangle, and that we know the sides of the right triangle. Normally we call the sides of the right triangle as the longest side as hypotenuse, then base, and then altitude. When we are about to write the trigonometric ratios, we have to mention the sides in a different way. That means with respect to here the angle marked is angle x. For angle x, if I name this triangle as triangle ABC, for angle x, this BC is adjacent side. BC is the adjacent side of angle x, and CA is also adjacent side, but being a right triangle, it is a side opposite to a right angle, so we have to call it as hypotenuse itself. Okay, so among the two adjacent sides in a right triangle, CB and CA, we have to mention CB as adjacent side and CA as hypotenuse itself. And the side AB, which doesn't have any direct connection with the angle, we have to call it as opposite side. So moreover, AB is the side opposite to angle x. So AB is the opposite side. So remember, in a right triangle, with respect to a particular angle, there will be adjacent side, opposite side, and hypotenuse. And trigonometry tells us the relationship between this angle with respect to any of these two sides. Let us see which are the trigonometric ratios. Basically, there are 6 trigonometric ratios, and we can see them one by one. The first ratio is here in this example, in this figure, here you see this right triangle, the right triangle mentioned here, angle is marked as theta. What do you mean by theta? Theta is the acute angle of a right triangle. So you can mention either this angle theta or this angle theta. But here now we have selected this as theta, and we are going to write the 6 trigonometric ratios with respect to angle theta. So the first first ratio is sine of theta. Okay, what's the first ratio? It is the sine ratio. Actually, the spelling is SINE, but we'll be denoting it SIN, sine theta. Sine theta is the ratio of opposite side of theta to hypotenuse. What's the first ratio? It is sine of theta, sine of the angle. That means opposite side of angle theta divided by hypotenuse. And second ratio is cos theta. Cos theta is the ratio of adjacent side of angle theta to hypotenuse. What's the second ratio? Cos of angle theta, cos ratio, that is adjacent side of angle theta divided by hypotenuse. And the third ratio is tan of theta, tan ratio. Tan ratio is the opposite side of angle theta divided by adjacent side of angle theta. With respect to angle theta, we have written these 3 ratios. These are the very important 3 ratios, and the remaining 3 ratios are the reciprocals of these 3. That means the reciprocal of sine ratio or the reciprocal of sine theta is called the cosec of theta, cosec theta. Since it is the reciprocal of sine theta, we can mention it as cosec theta equal to 1 by sine theta, because Reciprocal of x is 1 by x. Reciprocal of 2 is 1 by 2. Similarly, reciprocal of sine theta is 1 by sine theta, which we call as cosec theta. So, listen, cosec theta is the reciprocal of sine theta. So, it is 1 by sine theta. If we mention it in the form of a ratio, we have to say cosec theta equal to hypotenuse by opposite side. Next is reciprocal of cos theta, which is sec theta. So, sec theta is 1 by cos theta. In the form of ratio, it is hypotenuse divided by adjacent side of theta. And the reciprocal of tan theta is cot theta. That means cot theta is 1 by tan theta. In the form of ratio, cot theta is adjacent side of theta divided by opposite side of theta. So, the 6 trigonometric ratios are sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta. It is easy for you to study, or it is better to remember the 6 ratios in pairs. 3 pairs means sin theta, its reciprocal, cos theta, its reciprocal, tan theta, its reciprocal. So, you can study like this. Sine ratio of theta or sine of theta is opposite side of theta divided by hypotenuse. Then cosec theta is hypotenuse divided by opposite side. Then cos theta is adjacent side of theta divided by hypotenuse, whereas sec theta is hypotenuse divided by adjacent side of theta. And tan theta is opposite side of theta divided by adjacent side of theta, and cot theta is adjacent side of theta divided by opposite side of theta. Study like this, okay? Let's see the ratios once again. Here the name of the functions and the name of the functions are given here. This is a normal name, actual name, and here the abbreviations are mentioned over here. So we have to stick on this abbreviation. Sine is actually a sine, cos is cosine, tan is tangent, cosec is cosecant, sec is secant, and cot is actually cotangent. In the previous example, we have written the ratios, trigonometric ratios with respect to angle theta. Here we are writing the trigonometric ratios with respect to angle A. Instead of theta, angle A is taken. So, sin A is opposite side by hypotenuse, cosec A is hypotenuse by opposite side, cos A is adjacent side by hypotenuse, sec A is hypotenuse by adjacent side, and tan A is opposite side by adjacent side, and cot A is adjacent side by opposite side of angle A. Study it very well. Sin, cosec, cos, sec, tan, cot. Study the ratios very well. Okay. Now we are moving to the textbook exercise questions. Let me explain it very fast. First question here. In triangle ABC, right angle that AB is 24 centimeter, BC is 7 centimeter. Determine sin A, cos A, sin C, cos C. So, what's the question here? In triangle ABC, right angle at B. Here in this figure, you see triangle ABC is right angled at B. And we are given AB is 24 and BC as 7 centimeter. Determine sin A, cos A, sin C, cos C. And we know very well sin ratio is the ratio of opposite side of angle A to hypotenuse. So it is very much compulsory, or we must find what is the length of hypotenuse. And this being a right triangle, how can we find the length of hypotenuse? We have to find it using Pythagoras theorem. So here the ratios are expanded ratios are written. So for finding the length of AC, we have to use Pythagoras theorem, where AC square is equal to AB square plus BC square. So 24 square plus 7 square, 576 plus 49, 625. AC square is 625. So AC is root 625, which is equal to 25. Next we have to write the sine ratio. Sine of angle A. Sine A is asked here. Sine of angle A means opposite side of angle A divided by hypotenuse, that is 7 by 25. Then cos of angle A, adjacent side of angle A divided by hypotenuse, that is 24 by 25. Next ratio, sin C and cos C. We have to write sine ratio and cos ratio with respect to angle C, not for angle A but for angle C. Sine of angle C is opposite side of angle C by hypotenuse, that means 24 by 25. Then cos of angle C is adjacent side of angle C by hypotenuse, that is 7 by 25. Okay. Next problem. Question number 2. In figure, find tan P minus cot R. Very simple question. Figure, right triangle PQR. In right triangle PQR, right triangle PQR is right angled at Q. PQ is 12 cm given and PR is 13 cm. It is given. And we have to find tan P. Tan P with respect to angle P, we have to write tan ratio. And tan P is opposite side of P divided by adjacent side of P. And here we have to find the opposite side. The opposite side is actually QR. It is not given. So we have to find QR. Using Pythagoras theorem, we can say PR square is PQ square plus QR square. So from there, we can write QR square equal to PR square minus PQ square. That is 13 square minus 12 square. 169 minus 144 is 25. QR square is 25. So QR is root 25, which is equal to 5. So we got this side as 5 centimeter. Now see, opposite side of P, we got it as 5 centimeter. Okay. Opposite side we got as 5 centimeter. Now we can write the ratios. Tan P is opposite side of P divided by adjacent side of P. That's equal to 5 by 25. Then cot R, with respect to R we have to write cot ratio. Cot is reciprocal of tan R. Cot ratio is adjacent side of R divided by opposite side of R. Adjacent side of R is 5, opposite side of R is 12. So that is also 5 by 12. So we have to find tan P minus cot R. Tan P is 5 by 12, cot R is 5 by 12. So 5 by 12 minus 5 by 12 equal to 0. That is the result. That is the answer. Okay. Next question. Question number 3. If sin A equals 3 by 4, calculate cos A and tan A. In this figure, if sin A is 3 by 4, sin A is given with respect to angle A, the sine ratio is given. And we know sin A is opposite side of angle A divided by hypotenuse. So that is equal to 3 by 4. It is given. So on comparing those ratios, numerator and denominator, we can say opposite side of angle A is 3 and hypotenuse is 4. Here is A, opposite side of angle A is 3 and hypotenuse is 4. Now certainly we have to find cos A and tan A. Cos means it is adjacent side of A by hypotenuse. So we have to find the adjacent side. Adjacent side means AB. Similarly, we have to use Pythagoras theorem here. AB square equal to AC square minus BC square. So 4 square minus 3 square, 16 minus 9 is 7. So AB square is 7. So AB is equal to root 7 centimeter. It is written here. Now we have to find cos A. This is root 7 centimeter. Cos A means adjacent side of angle A divided by hypotenuse. So it is root 7 by 4. Then tan A means adjacent side of angle A divided by opposite side of angle A here. So it is, tan A is opposite side of angle A divided by adjacent side of angle. Tan A is opposite side of angle A divided by adjacent side of angle A. So it is 3 by root 7. That's all. Next question. Question number 4. Given 15 cot A equal to 8, find sin A and sec A. Okay. Here 15 cot A equal to 8. From there we have to find cot A. Transpose that 15. On transposing 15 we will get cot A equal to 8 by 15. We will be able to find the third side or the hypotenuse of this triangle only by writing this step as a ratio. Okay, so cot A is 8 by 15. Cot A we can write it as cot of angle A means opposite side of angle A divided by adjacent side of angle A, that's 8 by 15. So if you are getting 8 by 15, then only we can compare the numerator, denominator and write those values here. So opposite side of angle A will be 8, which is written here, and adjacent side of angle A is 15. Okay, and sine A is opposite side by hypotenuse, so we have to find the hypotenuse also. So remember, in a triangle, if a ratio is given, the three sides of the triangle must be known. So the first step is to find the three sides of the right triangle. So here it is. Here we have to find which side? BC. AC. We have to find the hypotenuse AC. So AC square is AB square plus BC square. 15 square plus 8 square. That is 289. So AC is a root of 289. That is 17 centimeter. Here this step is very important. 15 cot A equal to 8. So that cot A equal to 8 by 15. We have to convert the RHS also in the form of the ratio. Then only we will be able to compare the numerator and denominator here. So since we got AC equal to 17 centimeter, sin A is opposite side by hypotenuse, that is 8 by 17, and sec A is the reciprocal of cos A. So it is hypotenuse by adjacent side. So hypotenuse is 17 centimeter, adjacent side is 15 centimeter. So it is 17 by 15. Okay. Next question number 5. Given ck equal to 13 by 2, the similar type of question, so I am not explaining it much more. Ck equal to 13 by 12, calculate all other trigonometric ratios. Ck is 13 by 12, hypotenuse by, sec means hypotenuse by adjacent side 13 by 12, 13 by 12. So find the missing side BC. Pythagoras theorem. Using Pythagoras theorem we got BC equal to 5. This side is found and have written all those asked. All other trigonometric ratios. All the remaining trigonometric ratios are written. It's a very simple question. Next one, question number 6. Is also an easier one. If angle A and angle B are acute angles such that cos A equal to cos B, then show that angle A equal to angle B. What's given? Angle A and angle B are acute angles such that cos A equal to cos B. So let's start with cos A equal to cos B. In this figure, cos of angle A, what is cos A? Adjacent side of angle A divided by hypotenuse. So adjacent side of angle A is AC by hypotenuse is AB. So LHS and RHS we are substituting the ratio of sides. So cos A is written as AC by AB. And cos B with respect to angle B, what is the cos ratio? Similarly adjacent side by hypotenuse. So adjacent side here is BC. So it is BC by AB. And you see these two. It is actually AC by AB equal to BC by AB. We got like this. And you can see this AB and AB, or 1 by AB, actually it is 1 by AB, 1 by AB is cancelled. And what is remaining there? AC equal to BC only remaining. That means side AC equal to side BC. And we have studied in the previous classes that if two angles are equal, sides opposite to them are also, if two sides are equal, then angles opposite to them are equal. Both the definitions are correct, but here we have to prove angle A equal to angle B. Okay, so we got side AC equal to side BC in a triangle. If two sides are equal, angles opposite to them are also equal. So, angle A equal to angle B. Okay. Question number 7. Also simple one. If cot theta equal to 7 by 8, evaluate 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. What is given here? It's an important question. You are given that cot theta equal to 7 by 8. 7 divided by 8. And you have to evaluate this one. This expression. In this expression, sin theta and cos theta are mentioned. So what we have to do is, we have to find the ratio values of sin theta and cos theta, substitute here and simplify. That's all. For finding sin theta and cos theta, we should know the hypotenuse. So for finding the hypotenuse, use Pythagoras theorem. Before that, cot theta is 7 by 8. Cot theta means adjacent side of theta by opposite side of theta. So adjacent side of theta is 7. Opposite side of theta is 8 units. Okay, so by Pythagoras theorem we can find AC. So AC square is AB square plus BC square, 7 square plus 8 square, that is 113. AC square is 113, so AC is root 113. So for evaluating this one, we must find what is sin theta and cos theta. Sin theta is opposite side by hypotenuse, so 8 by 13, and cos theta is adjacent side by hypotenuse, 7 by root 113. Sin theta is 8 by root 113 and cos theta is 7 divided by root 130. Now we have to evaluate it. For evaluating, you write the question part as it is here. 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. Substituting the values of sin theta and cos theta, 1 plus sin theta means 1 plus 8 by root 113. 1 minus sin theta is 1 minus 8 by root 113. 1 plus cos theta is 1 plus 7 by root 113. 1 minus cos theta is 1 minus 7 by root 113. And you see here, this is in the form a plus b into a minus b. Here also a plus b into a minus b. And a plus b into a minus b we know is the identity a square minus b square. So 1 plus 8 by root 113 into 1 minus 8 by root 113, we can say 1 square minus 8 by root 113 whole square. Similarly, denominator 1 plus 7 by root 113 into 1 minus 7 by root 113 can be written as 1 square minus 7 by root 113 whole square, written in the form of identity. 1 square is 1. 8 by root 113 whole square is a by b whole square is a square by b square. So 8 by root 113 whole square is 8 square 64 divided by root 113 whole square means it is 130. So here 1 square is 1, 7 square is 49, root 113 whole square is 113. So, cross multiplying the numerator and simplifying, here cross multiplying 113 minus 64 by 113 divided by 113 minus 49 by 113. 113 cancel, remaining 49 divided by 64. It's very important question. Okay. Do the simplifications very carefully. Next one. If 3 cot A equal to 4, check whether 1 minus tan square a by 1 plus tan square a equal to cos square a minus sin square a. The first part of the problem is so simple. We have done similar problems. 3 cot a equal to 4. From there we have to find cot a. Cot a equal to 4 by 3. The RHS we must get in the form of a ratio. Then only we can substitute over here. So cot A is 4 by 3, adjacent side of angle A by opposite side of angle A is 4 by 3. So we got adjacent side of angle A, AB is 4, opposite side of angle A, BC is 3. Using Pythagoras theorem, we found hypotenuse is 5 centimeter. Now we have to check whether 1 minus tan square A divided by 1 plus tan square A equal to cos square A minus sin square. This is LHS, it is RHS. So I have taken here LHS first. LHS is 1 minus tan square A by 1 plus tan square A. 1 minus, what is tan square A? Tan square A means whatever is tan A, that whole square. If tan A is 2 by 3, tan square A means 2 by 3 whole square. If tan A is 1 by 2, tan square A is 1 by 2 whole square. Here cot A is 3 by 4. So tan A is certainly cot A is 4 by 3. So tan A will be 3 by 4. So 1 minus tan square A means 1 minus 3 by 4 whole square. 1 plus tan square A means 1 plus 3 by 4 whole square. That's equal to 1 minus, here is written 3 by 4 whole square is 1 minus 9 by 16. Here 1 plus 9 by 16. Cross multiplying and simplifying. 16 minus 9 by 16, 16 plus 9 by 16, 16 is cancelled. Remaining 16 minus 9 by 16 plus 9, 7 by 25. Now see the RHS. RHS is cos square A minus sin square A. What is cos A? Cos A is 4 by 5, right? Adjacent side of A by hypotenuse, that is 4. So cos square A is 4 by 5 whole square. And sin square A is sin A whole square. Sin A is 3 by 5. So 3 by 5 whole square. So 4 by 5 whole square is 16 by 25. 3 by 5 whole square is 9 by 25. 9 by 25. So 16 by 25 minus 10 by 25 is 7 by 25. So these two are equal. So LHS equal to RHS. That means 1 minus tan square A by 1 plus tan square A equal to cos square A minus sin square A. They are equal. And question number 9. In triangle ABC right angled at B, if tan A equal to 1 by 3, find the value of first one. What is first one? Sin A cos C plus cos A sin C. Here first example I will give, second example you have to do. Sin A cos C plus cos A sin C. That means sin A into cos C plus cos A into sin C. Here the angles are given alternately. Here first sin A, then cos C, then cos A, then sin C. Similarly, we have to proceed in the previous ways. Tan A is equal to 1 by root 3. So opposite side of angle A by this 1 by root 3. So find the hypotenuse by Pythagoras theorem. We have got it is 2 centimeter. Then evaluate the first one. Sin A cos C plus cos A sin C. Sin of angle A means opposite side of angle A divided by hypotenuse is 1 by 2 into cos C with respect to angle C. Cos ratio means adjacent side of angle C by hypotenuse. That's also 1 by 2. Then cos A. Cos A means adjacent side of angle A by hypotenuse root 3 by 2. And sin C is opposite side of angle C by hypotenuse root 3 by 2. 1 by 2 into 1 by 2 is 1 by 4. Root 3 by 2 into root 3 by 2 is numerator. Root 3 into root 3 is 3. 2 into 2 is 4. 3 by 4. So 1 by 4 plus 3 by 4 is 4 by 4. That's equal to 1. Now cos A cos C. Cos A means root 3 by 2 into cos C is 1 by 2. Okay. And sin A is, sin of angle A is 1 by 2 into sin C is root 3 by 2. So root 3 by 2 into 1 by 2 minus 1 by 2 into root 3 by, these two are same. 1 by 2 into root 3 by 2. So 0. Okay. 2 problems. And the last question that I am going to discuss here is this problem. What is it? In PQR, right angled at Q, PQ plus QR equal to 25 centimeter and PQ is 5 centimeter. Determine the values of sin P, cos P and tan P. In this figure, right triangle PQR, right angled at Q, you are given PQ is 5 centimeter. It is given. And PR plus sum of these two sides are given to be 25 centimeter. So no other clue is given. We doesn't know the length of any of these two sides. So we have selected one side among that is X and sum of the two sides is 25. If we select one side as X, the other side will be 25 minus X. Okay. So here we have selected QR is X. So PQ is equal to 25 minus X. So it is not possible to do the problem by keeping it as X or this as 25 minus X. We have to find the exact value. So that we are depending on the Pythagoras theorem. By Pythagoras theorem we know PR square equal to PQ square plus QR square. PR here we have written as 25 minus X, that whole square equal to PQ is 5 and QR is X, 5 square plus X square. And this 25 minus X you expand using the identity A minus B whole square. 25 square minus 2 into 25 into X is 50X plus X square. RHS it will be 5 square plus X square, only 5 square here written as 25. And here you see X square can be cancelled. And what is remaining? 625 minus 50X equal to 25. This is only remaining. Now I am transposing the constant to the same side. So 625 minus 25 plus 25 is here. On transposing it became minus 25 equal to 50X. 625 minus 25 is 600 equal to 50X. So X equal to 600 by 50. 0 cancelling. We will get X equal to 12. And if we get X equal to 12, X equal to 12 means QR equal to 12. Okay, if we get X equal to 12, we can find 25 minus X also. So 25 minus X is 25 minus 12 equal to 13 centimeter. So it is written here. So we got here these values as PQ equal to 5, QR equal to 12 and PR equal to 13 centimeter. Now we are able to write the trigonometric ratios. I think it is not visible here. Okay. We have to find sin P, cos P and tan P. Sin of P is opposite side of P by hypotenuse. It will be 12 by 13. And what is cos P? Cos P is adjacent side of P divided by hypotenuse. That is equal to 5 by 13. And what is tan P? Tan P is opposite side of angle P divided by adjacent side of angle P, that is equal to 12 divided by 5. So this way we have to do this problem. This problem is very important. Remember, in this case lengths of two sides are not given. We are given the length of only one side. If the length of the two sides of a right triangle are given, we can directly apply Pythagoras theorem. Then we will get the constant at that moment itself. But in the case if the length of only one side is given and sum or the difference of other two sides are given, we have to depend on this method. One of the sides should be taken as X and the other side must be taken as 25 minus X. Whatever is the sum, that minus X. Then apply Pythagoras theorem. So dear children, all these 10 problems are very important. Do it very carefully in your notebook and clear the doubt if any. Okay, thank you.